Hello and welcome to Lab 6 of ME230 Basics of Mechatronics. This lab covered digital input and output handling, DC motor control, and analog signal measurement using Arduino. It was conducted by Group 6, which consists of the members Brendan Meyer, Bashar Anwar, Preston Cryer, and Jack Blackwell. Hey, it's Bashar Anwar, and I'll be going over the agenda. The introduction will be done by Brendan Meyer, the experimental details by myself and Preston Creer, the experimental procedure and results will be done by Jack Blackwell, the discussion by Preston Creer, and the conclusion done by Brendan Meyer. Enjoy.
Hello, I'm Brennan, and I'll be covering the introduction. The goal of this lab was to see how the Arduino operates by testing it on open-loop systems. The motivation was to explore the use of Arduino since it's capable of executing code. This allows for more complex systems to be run with breadboards and expands the functionality of any circuits that we build. Now looking at the experiments, Experiment 1 used a signal from the Arduino to turn on a green LED. Experiment 2 used a button to turn on the red LED when the button is pushed. Experiment 3 created a loop in the code which changed the signal between the green and red LED. Next experiments utilize a motor and a motor driver. When the motor is going, the red LED will be on, and when the motor is off, the green LED will be on. Experiment 4 makes the motor turn on when the button is in an active state. Experiment 5 creates a loop which makes the motor spin and forward, then it switches to reverse. Experiment 6 reduces the duty cycle of the motor with each button press. Lastly, Experiment 7 will change the speed of the motor using a potentiometer. The green LED will always be on unless the duty cycle surpasses 75%, in which case the red LED will turn on.
Preston Creer speaking, and this is the components list of the experiments for experiments 2.1 to 2.3, 2.4 to 2.6, and experiments 2.7. The components table has the symbols on the left and the descriptions on the right.
Hello, it's Bashar Anwar, and I'll be covering some of the experimental details, including the circuit schematic and how the resistance of the resistors were calculated. As you can see from the circuit schematic shown on the screen, the experiments begin with an Arduino that is connected to two sets of resistors and diodes connected in series separately, as well as a push button that is connected to the 5 volts that stem from the Arduino. Off of the push button node, there is a pulled down resistor that is connected to ground. Moving on to the second set of experiments, we introduce a motor controller and a motor. The motor controller has its own power and ground that connect to it directly, as well as 3 different connections that come from the Arduino. The DC motor connects to the motor controller, and that is how it gets its power. Finally, we end with the last experiment, which introduces a potentiometer that connects from AO of the Arduino and also gets 5 volts from the Arduino as well. In order to find the correct resistance for our circuit, we use the following equations and circuits shown on screen. For the resistors in series, equation A is used. V out pin minus Vf is the voltage drop across the resistor itself, that being 5 minus 2.2 respective to V out pin and Vf. That is divided by the current that is given as a range of 5 mA to 15 mA. Our resistor must fall between these two values. Using equation B, we find the pull-down resistance. The VCC is 12 amps from the motor controller, and ILK is the leakage current from the Arduino. We need to make sure that we are using the low-level voltage, which is 0.3 times VCC. Having a value of resistance that is less than this value will ensure our circuit works properly.
And again, and to understand how the code affects the components, we're going to look at the push button or the switch. And when it is pressed, the pin 4 will read as high, and the Arduino reads that as high in the code, which also means on. And when looking at the red and green LEDs using the experiment, the Arduino will set these pins to high or low in the code, and that will either turn the LEDs on or off. Code also has an effect on the DC motor control, as analog write, the code analog write, is used to control motor speed. Also, inputs 1 and inputs 2 can control the direction via digital pins 2 and 4 on the Arduino. The Arduino will set the input 1 and input 2 to either read high or low, and this will create combinations to either rotate the motor forward or reverse or to stop it. And below are some example code for how that would affect the motor. Finally, the code also has an effect on the potentiometer through the analog sensor in experiment 2.7, and the potentiometer is connected to the pin A0 on the Arduino, and this will read the analog value using analog read in the code, and this input is used to either control the motor speed, to trigger LEDs to turn them on or off, or also to log or display the sensor values of the potentiometer.
Hi, it's Jack Blackwell, and I'll be talking about the experimental procedure and results. This Arduino code is used to turn on the green light. The first line of code assigns the 8th pin on the Arduino with the green LED and also sets it as an output, and then it turns on when setting it to high. Similar to Experiment 1, Experiment 2 uses the first couple of lines of code to designate what is connected to each pin. Then there is an if statement to check whether the push button is pressed, and if it evaluates as true, then the red button is set to high and turns on. Experiment 3 uses the same button press to initiate a pattern, turning the green light on, delaying it for 2000 milliseconds, which is 2 seconds, then turning the red light on. Then it repeats this code to do it again. The fourth experiment introduced the motor, which meant we needed a motor controller, which was supplied with power. The pin that goes to enable is set to high, which essentially powers the motor. Direction A and B are opposite directions. To turn on motor A in a certain direction, the direction A pin is given power and the direction B pin is not by setting it to low, and vice versa. The same power that was sent to the motor is also sent to the red LED pin, so when the motor is on, the light is also on. Experiment 5 does a pattern of one direction, then switches directions, and then stopping for a predetermined period of time using the delay function, and then it repeats this pattern. In experiment 6, the first time you press the button, the motor runs at full power using 100% duty cycle, then it stops. The next time you press the button, it'll run at a 70% duty cycle and then stop, and it keeps dropping every time you press the button. It uses the same motor controller pin setup as the last experiment. In experiment 7, a potentiometer is introduced to control motor power. It is connected between the Arduino and motor controller. When the button is pressed, the motor starts and the potentiometer controls how much power the motor gets and correlates it with the speed. This is done by dividing the potentiometer output and correlating it with the PWM value. It displays the percentage the potentiometer is turned to in the serial monitor.
Potentiometer. This is Preston one last time to talk about the discussion. So what went well during this experiment was that the circuits were all built swiftly and accurately, and all of the members were able to work together to be more efficient during this experiment. We were all able to observe how the different code through the Arduino interacts with the circuits, and this changes the LEDs, making them turn on or off, or as well as reversing or speeding up the motor. Every member was also able to build and adjust the circuit to perform the necessary experiments, as in everybody was able to complete the circuits for the experiments. What did not go well during this experiment was that one member's motor driver was malfunctioning and not turning the motor on, and even after troubleshooting, the problem was not solved. Eventually, the TA was able to find a missing piece that was left behind that had fallen off of the motor driver, and once it was put back on, the motor driver worked properly, and there were no other problems.
Hello again, this is Brennan, and I'll be covering the conclusion. The goal of this lab was to design open-loop systems and test them with the Arduino, which our group believes we covered very well. The first 3 experiments focused on manipulating diodes with the Arduino. Experiments 4 through 6 showcased how a motor could be used with it, and lastly, Experiment 7 added a potentiometer to the circuit, which allowed for control over the speed of the motor. This lab ran smoothly, as our group was able to use what we learned over the course of the semester to properly analyze these circuits and troubleshoot any problems that may have risen. Thank you so much for listening to this presentation, and thank you for the experience that